Hi, I am Professor D.K. Panda from the Ohio State University. Together with my colleagues, Professor Harish Subramani, Navaras Al-Nashan, and Jinghan Yao, we are very excited to bring you this tutorial which will be offered at Supercomputing 2025. The title of the tutorial is Principles and Practice of Scalable and Distributed Deep Neural Networks Training and Inference. As you know, we are in the field of very exciting field of AI, which comprises of many subfields, especially in this case, the machine learning and deep learning. And, uh, and in that context, we are going through a lots of rapid changes, not only on the system side, but algorithm side and also on the application side, trying to see how this AI field can actually have an impact on a lot of different disciplines. So this is the field of AI, or especially machine learning, deep learning, has been there in the field for many, many years. As you can see, like it has been there for hundreds of years. People have been talking about this, but especially in the last 10 years, a lot of changes are happening. And those things are happening especially in the context of newer CPU, GPU, newer interconnects, newer kinds of system integration, and then the software innovations. And all these things being put together, we are leading into the next phase of the AI. So in this context, there is of course the main thing is to have really training. Once you have a lot of data, how do you actually build an AI model? And as the data sizes are increasing, the model sizes are also continuously increasing. You must have heard of or used even ChatGPT and all the related models, the LLaMA, O2, O3, all these are coming up. But the main thing is that when you try to build this kind of a model or take care of the training, especially with huge amount of data, a single GPU is not sufficient. So in that context, you have to use hundreds and thousands of GPUs for many months to really build this model. And this is the very hardcore problem the community is trying to solve, which is called the parallel and distributed training. And especially you in that context, multiple issues come up like how do you build this system, how do you integrate like scale up technologies, scale out technologies, building the collectives, communication libraries, overlapping the computation with communication. All aspects of parallelism and distributed computing actually needs to be totally enhanced and integrated together to solve these kind of problems. Now, of course, now we are in a Gen AI world. So it is not just the training, but using the models, how we can actually use, let's say, LLMs and with inferencing, following an iterative loop, which we can actually generate tokens or words and is fed back to the input for the next. And through these, we are trying to do online LLM inferencing. And of course, there are a lot of metrics here like latency. There are concepts of efficient batch processing, mixed precision support, and of course, under the hood, we need to make sure that these things are also running on systems with high performance interconnects and high memory bandwidth. So, so as I indicated earlier, so a lot of these opportunities exist because of the modern GPU architecture. So here it shows like how the high performance architectures in the top 500 list are actually providing catalyst to these kind of systems, as well as like a lot of continuous things are happening with the ImageNet challenge. Data is being open. So one has a lot of this kind of understanding one needs to have to make sure that the complete ecosystem is working well. So in that context, if you are a person working in this area or if you are a person interested in working in the area, you'll have a lot of questions. For example, like how to understand the DNN training or inference performance in a holistic way, how to correlate low-level performance to high-level metrics. Question comes, do we need like a dedicated collective communication libraries, or the commonly used MPI, which is message passing interface runtime, is good enough to take care of the training and inferencing? And especially as the model sizes are becoming larger, you may not be able to fit them within a GPU. So then how do you handle out of core DNN training? And in this context, there are a lot of open issues at the intersection of DL and HPC. And you might have a lot of questions saying how your work actually will be helping in that context. And especially the GPU, modern GPU architectures, the way they are programmed, how to exploit them for both machine learning and deep learning, and also like how to design distributed training frameworks for ML. So these are just a sample of questions, but you might be having many more questions on your mind, especially looking at this field. So to broadly put all together, the broad challenge the field is going or the community is trying to exploit HPC and trying to see how to efficiently scale out both machine learning and deep learning frameworks and take advantage of the heterogeneous high performance computing or the HPC resources. So when we say heterogeneous, these are the CPUs, GPUs, DPU, IPUs, XPUs. A lot of these units are being designed over the years. So in order to put everything together and to answer all your questions, we have this tutorial organized in this manner. We'll be starting with a very high level introduction, going over the machine learning, deep learning frameworks, trying to provide you guidelines on overview of the execution environments and how these modern DL frameworks and supporting libraries work together with the machine learning algorithms. And then we'll be moving into deep neural network training and give you a perspective of the evolution of vision models as well as language models. And then gradually we'll go into down. We'll start with saying what are the basic principles and guidelines to take care of distributed data parallel training. And in that section, we'll actually be covering very nice hands-on exercises so that you can actually play with on a GPU cluster with PyTorch and TensorFlow. And once you understand this distributed parallel training, we'll take a look at what is happening in the HPC, especially with all the different technologies coming up for DL and ML. And based on those architectures, we'll try to go over the advanced distributed training, which basically provide support for different kinds of parallelism like a model parallelism, hybrid parallelism, spatial parallelism, temporal parallelisms, and especially one aspect, the hybrid parallelism, we'll be doing a hands-on exercise. And once we have a very good understanding of the training aspect, we'll go into the distributed inference because that is becoming much more challenging these days when you have like a chat GPT kind of system is trying to handle millions of queries at any given time. How do you actually take care of that in a backend in a very efficient manner so that the users get the responses with a very low latency? And in addition to the training and inference, we'll also be taking a look at the distributed hyperparameter optimization. That also is becoming more challenging these days. And here we'll be covering like exhaustive and iterative search methods, and we'll also be taking care of some hands-on exercises. And we'll be concluding with some open issues and challenges. So as you saw, this tutorial will try to provide you a very broad perspective of the principles as well as practice, both the training and inferencing. So it will be a full day tutorial. It is scheduled on Sunday, 16th November in room 131 from 8:30 in the morning to 5 o'clock. And more details on this tutorial available from this link. So I'll strongly encourage all of you to join us, not just for the conference, but also for this tutorial. And between now and the tutorial date, if you have any questions, please feel free to ask us. The email addresses are given below. And we look forward to seeing you at the tutorial. Thank you.